proper hour. We're going to move forward. People will be coming in as we speak, I'm sure. So we're going to move forward, as I said, with our next panel. And with us today for a safety update, well, I'll leave it right there and leave a bit of mystery in the air. So with us today is Gilberto Lopez Meyer, Senior Vice President of Safety and Flight Ops, and also Katya Vashchankova, and you'll have to wait for her title.
Thank you very much. Thank you, Perry. So thank you all for being here to give you an update of the safety and flight operations area. So far, 2018 has proven to be a challenging year in terms of safety performance. I will present some high-level statistics produced through our data programs. The statistics presented are current as of July 1st, which is the last time the data has been updated by the Accident Classification Technical Group, or ACTG. This is a team made up of airline, manufacturers, and other industry experts. The first half of 2018 has seen 32 accidents, with 5 hull losses, 2 involving jet aircraft and 3 involving turboprops. There were a total of 5 fatal accidents, which accounted for 301 fatalities. This compares with only 42 accidents and a total of 19 fatalities, only 19 fatalities all last year. So a very different outcome so far. Unfortunately, since the ACTG met in June, there have been another 216 fatalities. And I will cover it in my slides later during this presentation. As we mentioned before, in the 2018 annual safety report, continued awareness and safety work is required to maintain and improve the global level of safety performance in our industry, which in 2017, just last year, we saw at its best. The IATA Accident Classification Technical Group works in this direction, analyzing each single accident and identifying the primary and secondary contributing factors associated with them so that the industry can continue to learn and to improve. As I mentioned before, in the second half of 2018, figures are approximate because ACTG has not reviewed the data for second half of the year yet. However, we know that in this period we had 6 fatal accidents, which accounted for 216 fatalities, bringing the total number of fatalities for this year to 517. The accident that just occurred in late October in Indonesia accounts for a big number of these fatalities. The preliminary investigation report has been published recently, very few days ago, and the ACTG will be reviewing it in January to capture the lessons learned so far. As I like to say, and I have said that before here, these accidents this year in 2018 remind us that safety improvement is a marathon with no finish line. No finish line. We cannot be complacent and must continuously look for new ways to improve safety. The first half of 2018 has worse performance than the previous year. But we can clearly see the improvement compared to 10 years ago. It is important to remember that the accident rate has been at all-time lows in recent years. So our focus should be on maintaining an overall decreasing trend through the years. IATA members keep performing well with an accident rate below the overall industry. But let's remember that our work is dedicated on making the overall industry safer, every single airline included. This slide shows a breakdown per IATA region on the all-accident rate, comparing the performance of the first part of 2018 with previous years. You can see that in 4 out of 8 IATA regions, the accident rate increased compared to 2017. two regions' accident rates remain significantly above the global average: Africa and the Commonwealth of Independent States, the previous Soviet Union states, indicating that more work is required to improve safety in these regions. However, it is encouraging so far this year that we see significant improvement even in those regions, in those two regions, over the 5-year average. The accident rate in Asia Pacific is overall improving too. But we should also consider that the industry in this region is expanding quite fast, contributing to the accident rate in reduction. The 5-year trend is showing a reducing accident rate in 7 out of 8 regions. Also, a positive trend to note is that sub-Saharan Africa continues to make a strong progress on safety, with 0 hull losses and 0 fatal accidents in the first half of this year. In this slide, we show the accident rates for IOSA versus non-IOSA members in the 2014-2018 time frame, broken down by IATA region. As in the past, IOSA registered airlines keep outperforming non-IOSA airlines in every single region. And with more than 435 airlines registered, 435, IOSA program is bringing a high value to operators all over the world. Now we will talk about portable electronic devices. This past year, ICAO, the International Civil Aviation Organization, asked IATA to tell them how compliant airline passengers were regarding the rules about where to pack PEDs. So IATA carried out a survey directly with passengers in 3 different markets: United Kingdom, United States, and Hong Kong. The questions were very diverse. For example, are you aware of regulations for the safe carriage of portable electronic devices? Or for example, do you pack any of the following items in checked baggage, namely power banks, electronic cigarettes, etc.? The results show that airlines are indeed well aware of the requirements, are informing their customers, and are experiencing very few incidents pertaining to PEDs in checked baggage. However, the traveler survey showed that 33% of travelers, 1/3 of travelers, rely on the check-in process for information on restrictions before deciding where to store their PEDs. Across all 3 regions that participated in the survey, the majority of travelers felt that they are well informed about the regulations. However, in all 3 regions, about 1/3 of travelers were still packing spare batteries and power banks in checked baggage. Interesting outcome of the survey. So they are less informed than they think. Or are they intentionally ignoring the rules? One thing was certain. That is, we need to raise awareness directly to the traveling public about this topic. The global total for passengers packing power banks in checked baggage is 36%, and the average number carried is 2. So it is assumed that if we assume that this is a representative sample, there may be a very, very large number of power banks in checked baggage at any one time. Spare batteries and power banks are still being carried in checked baggage. It was found also that business travelers tend to carry more of these restricted items than leisure travelers. And also that a higher percentage of business travelers pack spare batteries and power banks in checked baggage. And this is true across the 3 regions. So IATA we realized that there is a need to help airlines communicate the right and wrong way to pack PEDs before they arrive at the airport check-in. We wanted the message to be easily understood, without causing fear, but to communicate the what to pack and where. So we created an infographic in 8 languages and 3 different formats, a web page and a short video to highlight the campaign. And this is seen in the next slide. The key messages are very simple. It is better to keep all electronic devices with you in carry-on baggage in the cabin. This is not a regulation, but it is a very strong recommendation. As can be seen from the bottom of the screen, it is always best to check with the airlines, as there may be also local regulations or rules of individual airlines that impose other restrictions. The reason for that is that there are robust cabin procedures for dealing with any issues resulting from PED failure or malfunction. Electronic cigarettes, power banks, and spare batteries must not be carried on checked baggage. It must be complied all times. Items that are allowed in checked baggage must always be switched completely off. This is also very important, as hibernation or a sleep mode could mean that the device is drawing power and could be more prone to a potential failure. And this campaign was heavily posted on our social media channels, and airlines have told us that they are grateful to be able to access the simple poster directly from our website. We have also engaged airports around the world to use them. So, ladies and gentlemen, this is an important message. We would really appreciate if you, our esteemed members of the media, will also use your influence to communicate these messages to your readers and to your viewers. Thank you for considering this. Now we'll talk about the Global Aviation Data Management Program. The IATA Global Aviation Data Management Program, GADM, is a data management platform to improve aviation safety. GADM portfolio integrates all sources of global operational data from different channels and provides the industry with comprehensive and cross-database analysis. GADM is actually comprised of 4 main platforms: accident database, flight data analysis, analysis data exchange system, and ground damage database. Data captured in GADM in this program, in these databases, comprises accident and incident reports, ground damage occurrences, and flight data from over 470 different industry participants, airlines, airports, OEM, states, etc. Currently, we produce over 2 million reports in exceeds GTDB and 4 million flights in FDX, in flight data analysis. And I would like to share with you a short video to show you some of the dashboards that we produce with these programs. Please.
So IATA's Global Aviation Data Management Department is comprised of a wide portfolio of programs that collects data. We have the Flight Data Exchange Program, where we collect flight data from over 50 airlines. We aggregate it, we de-identify it, and we monitor it for trends. We also have the Safety Trend Evaluation and Data Exchange System, which is STEEDS, and we collect safety incident data from our 200 airline members. And again, we protect that data, we de-identify it, and we monitor it for trends also. And finally, we have our ground damage database, or GDDB. That's around 5 years old, but it's grown exponentially, which I think reflects the industry need for that kind of information. And currently, there are around 15,000 reports in that database. One of IATA's flagship publications is the Annual Safety Report, and that is derived entirely from the information collected in our databases, and specifically the accident database. Information is fed into the accident database off the back of the accident classification technical group, which meets twice yearly. They look at all of the accidents that have happened and they categorise them, and then we publish the information to our dashboards, and that information is available freely to anyone who signs up to use it.
Thank you very much. So, what is the future of GAD? What is the next step here? We recently started a project called Incident Data Exchange, or IDX, to upgrade the databases and dashboard suites to provide our members with enhanced data analytics and benchmarking capabilities through aggregated, de-identified global safety data. And GADM is working with more than 100 aviation industry safety professionals from around 40 different airlines, air navigation service providers, and safety agencies to develop the most up-to-date incident taxonomy called IATA Safety Incident Taxonomy, or ISIT. It allows us to better capture global industry risk, and it also includes a human trafficking and wildlife trafficking taxonomy. So this is a very good example of how data sharing can positively impact aviation safety, and honestly, we are very proud of this program. Now we'll talk about aircraft operational data. We define airline operational data, all data produced by the aircraft, its systems, components, and its sensors, once the aircraft is accepted into operation by an airline. This data is generated during the flight, when the aircraft or its engines and components are undergoing maintenance in the hangar, or while on the ground being serviced, for example, being fueled at the airport. Some of this data, part of this data, is transmitted to the ground during flight continuously, or is stored and collected on board and later transferred or downloaded on the ground. Data recording used to be a heavily manual process before. Traditionally, in the old times, a pilot had to write a technical deficiency on the airplane logbook. The mechanic had to read the handwritten note, take corrective action, and place his signature and stamp to ensure the work has been completed and the problem rectified before the aircraft could take its next flight. But a brand new aircraft today represents a technological marvel. All the manufacturers have done a super job in bringing new technologies on board the airplane. New sensors on board monitor thousands of parameters that ensure the safety of flights and assist pilots and mechanics to perform their job better and faster. Just as an example, about 400 different parameters are recorded in an Airbus 320 classic aircraft, 400. But over 24,000 parameters are monitored on a new Airbus 320 neo aircraft. Another example, an Airbus 320 classic aircraft generates about 200 megabytes per flight of information, while the Airbus 320 neo aircraft produces over 30 gigabytes, and information on the condition of the aircraft is transmitted to the ground before the aircraft arrives and used to avoid delays and cancellations and ensure a smooth travel for the passengers. Well, while the original equipment manufacturers, the OEMs, agreed that airlines, we the operators, own the raw data produced by their aircraft, occasionally they are restricting access to the airline operators, making it difficult for anyone else to utilize this data in a meaningful way. As data is produced, the airline should have every right to access and use of the data, because the airline is ultimately responsible for aircraft operations, their safety, sustainability, and integrity. The thousands of parameters monitored create numerous opportunities that can be exploited by data scientists working together with airline operations experts. So it is essential that industry stakeholders are sharing data and information to advance aircraft performance and operational efficiency. So, next steps. Our airlines have asked us to look into the various OEMs offerings and better understand how these new devices and these new services improve operations without restricting competition. IATA supports a healthy, competitive, and sustainable industry. To achieve this, each airline needs to be in charge of its own destiny. Therefore, be in control of its own data generated by its own aircraft. The airline needs to have choices regarding who will be collecting, transmitting, storing, and analyzing the data, and this work can be done in-house through a research institution, by another airline, or even by the OEM. This will ensure that data analytics, which is a recent and it's a new and fast-growing industry, is working with the airline business, promoting more innovation and more competition. As it happened before in the telecommunication industry, collaboration in the exchange of data under clear governance rules will keep the industry at the safest level while improving performance and efficiency. So this is a new topic that we, for sure, will need to talk more about it in the future. And now, I will ask Katya Vashchankova to speak to you about our Turbulence data sharing project that I am sure that you will find very, very interesting. Thank you very much for your attention. Katya, please.
Thank you, Gilberto. Now we'll hear from Katya.
Good afternoon. Buckle up, everybody. We're going to talk about turbulence and what IATA is doing to help airlines and passengers have a smoother ride. Why are we talking about turbulence and why is this topic so important to us? Turbulence is not just something that can make your flight occasionally uncomfortable. It's an important safety concern for many airlines. Turbulence is one of the main causes of injuries to passengers and cabin crew in flight. And it is the leading cause of injuries to passengers and cabin crew in non-fatal accidents, according to FAA. Turbulence also has an important economic impact on the airline operation, and airlines every year incur millions of dollars of costs. Most of these costs come from potential diversions, damaged cabin interiors, as well as excessive fuel burn that occurs when a pilot is searching for a smooth ride and could deviate from their optimal flight level. Unfortunately, most of the existing tools available to the pilots and dispatchers these days to manage turbulence have a number of limitations. The most important limitation is that there is no accurate information about the location and intensity of turbulence in real time. Pilot reports, for example, are quite subjective. When a pilot hits turbulence, they would send a report to the air traffic controllers, for example, saying that they've just experienced moderate turbulence. Well, to a more experienced pilot, it can be just some light chop. And to a pilot flying a very small aircraft, it can be a very severe turbulence encounter. So as you can see, it's quite subjective and is based on an aircraft size and pilot experience. Airlines also use turbulence forecasts, but they can be hours old and become obsolete by the time that the flight is in the sky. Turbulence can also be quite hard to predict in advance because it doesn't stay in the atmosphere for a long time in some cases. Finally, we have weather radars that help pilots avoid turbulence related to thunderstorms, but unfortunately they cannot detect clear air turbulence. So in many instances, the limitations of these tools lead to the fact that turbulence remains unforeseen and unanticipated, leading to injuries. So these days, airlines are actually turning to data as the industry is shifting to data-driven turbulence management. Thanks to the recent technology advancements, an aircraft in flight can now accurately calculate the turbulent state of the atmosphere around it in flight. It uses existing sensor parameters such as true airspeed, wind speed, pitch, angle of attack, and a few others that are put into a mathematical algorithm that calculates turbulence intensity on a scale from 0, which means smooth air, to 1, which means very severe turbulence. An automated report is then compiled containing these turbulence values, aircraft position, altitude, and a timestamp, and these reports are sent to the ground using standard communication systems. When an airline has access to this information in real time, it can then send this report to a following aircraft and alert this aircraft to the presence of turbulence. So a pilot can then either choose to avoid this area of turbulence, or if it's unavoidable, they can secure the cabin in time to avoid the injuries. So this is how this information is helpful to improve a safety performance related to turbulence. To give you a more real-time example of how this data is used, let's look at what Delta Airline is doing with this data as an example. So Delta Airline reports turbulence in this automated way, and they make this data available to their pilots during the flight using their own customized weather viewing tool, as you see here on the screenshot. So what happened during one of the flights a few days ago was that a pilot flying an aircraft requested a ride report from air traffic controller. ATC relayed to the pilot that the air was smooth. However, the pilot was looking at their tool, seeing some moderate turbulence ahead. So the data was showing turbulence when the air traffic was saying the air would be smooth. The pilot relied on the data and decided to secure the cabin. Subsequently, an aircraft hit moderate turbulence. Some unsecured items were tossed around the cabin. However, no one was injured because everybody was sitting in their seats with the seatbelt securely fastened. So this is an example of how the availability of this real-time data can help decrease injuries in a real-time operation. So many airlines are now adopting a similar approach by implementing a turbulence reporting capability and making this data available to their flight crew and ground operations personnel. However, the issue is that in many cases, airlines are only limited to using their own data, as this data is not shared in many cases. This leaves big gaps in coverage that actually makes it very difficult for pilots and dispatchers to plan and fly around turbulence. And it definitely limits the benefits of this data that could potentially be much more significant. To give you an example, imagine 3 aircraft from 3 different airlines flying in close proximity to each other. The first aircraft hits turbulence and sends an automated turbulence report to their ground control center. Well, the other 2 aircraft will hit the same turbulence because this data is not shared among these 3 airlines, which limits the benefits substantially in such circumstances. Therefore, IATA was requested by airlines to be a global turbulence data consolidator and to build a global data coverage for this data so that it's significantly more useful to the operators. Following this request, we have developed IATA Turbulence Aware platform, which is a tool for sharing real-time automated turbulence reports globally in real time, as I said. We have partnered with a UK-based company called Snowflake Software. They specialize in real-time data processing for various stakeholders such as NATS UK, NAV Canada, and other industry operators. And basically, they have worked with us for the past 6 months to develop this platform. What we do precisely is we collect automated turbulence reports from ground servers of airlines or their third-party providers. We consolidate this data, normalize it, perform quality control, and make it available for consumption in an anonymized way in real time. So the whole process takes us a few seconds presently with the data volume that we're working with now. However, the maximum processing time that airlines requested us to have is 30 seconds, so it's a real-time operation. Additionally, the idea is that once this data is available to airlines, they can integrate it into their own tools used by their pilots, dispatchers, or their OCC personnel. So IATA is being very flexible in how airlines can operationalize this data. We're vendor agnostic and trying to give airlines this level of flexibility. It's been a highly collaborative development, and we have created an important momentum in the industry by engaging a lot of major airlines. What you see here are the airlines participating in this initiative presently, and they're members of our Turbulence Advisory Group. When you earlier asked a question about how we engage low-cost carriers, here is an example of us working with Southwest, EasyJet, and WestJet and collaborating between members and non-members. Basically, this advisory group is helping us to define all the technical specifications for the platform to help us basically create a fair governance framework, as well as help us implement best practices when it comes to data sharing and data operationalization. I'm happy to let you know that we already have a live data feed from Delta, and United and Aer Lingus have also contractually committed to share their data through our platform. So the timeline for the development of this platform is the following. We have just completed the development of the first operational version of the platform with all the basic functionalities in place. Next year, we'll focus on onboarding live data from a number of other airlines, such as those that you just saw on the previous slides. We will let them test the platform in a real-time operation and collect feedback in order for us to implement a number of enhancements before the full launch of the platform in early 2020. And finally, to conclude, I'm just going to show you a brief screenshot of our Turbulence Viewer tool that is meant for the airlines that don't have any other tools to integrate this data into, at least for now. So it's a very basic, representation of color-coded turbulence reports on the map. So the white dots means that the air is smooth and there is no turbulence. It's a very important piece of information for pilots because it allows them to see the areas where turbulence can be avoided. So the dots that are colored basically represents turbulence of different intensity according to the color scale on the right. And as I mentioned before, it ranges from 0 to 1. We also have a filter by flight level so that pilots and dispatchers can have an idea of turbulence intensity at different flight levels, which can also help them choose the right flight level for the situation they're currently encountering. And if they click on the dot, they would see a detailed report that basically has an observation time, altitude, aircraft position, mean and peak turbulence, as well as real-time temperature and wind speed and direction. And as you see, all this is anonymized, so you cannot really configure which airline submitted this report, which is very important for the airlines to be able to share this information. So this is all just a very helpful situational awareness tools for pilots and dispatchers to make better decisions on how to manage turbulence during their operation. So this would be it for me, and I will pass the floor to Perry to basically moderate the Q&A session. Thank you very much for your attention.
Thank you very much, Katya.